Welcome, students. This is Dr. Carafano, the Chief Science Officer of Spacegate Station, calling you from Discovery 1, which is presently stationed directly over the dark side of the moon. We are here conducting detailed infrared mapping of the lunar surface so that we can develop a better understanding of its geological history. Today, you will get a chance to have a lesson led by Professor Miller, the Chief Science Officer from the Lunar Laboratory. Professor Miller is conducting her annual visit to Spacegate Station to perform a detailed system check of our AI system, Aurora. While she is here, she's going to share with you some basic concepts related to computer programming, which includes describing such things as algorithms and the part coding plays in the process. This is Discovery 1, over and out.
Discovery 1, this is Spacegate Station. We confirm your transmission. Please let Dr. Carafano know not to worry. We have everything we need for today's instructional recording with Professor Miller. Yes, our lesson today is in very capable hands. Mine, that is. I will update you after you pass through your communications blackout period on the dark side of the moon in approximately 35 minutes. Spacegate Station out.
Specialist Barber, do you have a sufficient break in your operational duties to discuss something that I am concerned about?
Of course, Aurora. You know me, I am always available to listen to the troubles of my teammates. Is this about your system shutdown today?
Actually, it is. To conduct a detailed system check, Professor Miller will be required to shut down the individual processing nodes that control my upper-level intelligence, specifically those areas that control my reasoning, problem-solving, knowledge representation, learning, language processing, and social intelligence.
That is correct, Aurora. To ensure all your systems are functioning properly, she actually has to systematically shut down all of your advanced digital pathways. And then she's going to run a system diagnostic. It's the only way to make sure that you're running at peak efficiency and that you're healthy.
I find the process of shutting down all but my most basic functions somewhat disturbing. What will happen to me when those systems are shut down?
Well, that's a good question, Aurora. And a good question like that deserves a good answer. Engineer Walker, could you come here for a minute?
Hey, what's up?
Aurora is really nervous about her shutdown procedures today. She wants to know what will happen when Professor Miller shuts down all her advanced digital systems.
Okay. Well, basically, her general pathways will just temporarily not be functioning. She'll still be running, but her base operations and everything will be doing what it's always been doing.
Okay. Well, now I think Engineer Walker, she's more concerned about what will happen as in like, what will it feel like when she's shut down?
What would it feel like? Now that's a different question. Let's see. Well, Aurora is intelligent, and shutting her down, at least in her main system, is kind of like putting her to sleep. I guess she'll be dreaming.
Processing. Dreaming functions as in offline memory reprocessing, in which the brain consolidates learning and memory tasks and supports and records waking consciousness. Dreaming may reflect unconscious mental function, the incorporation of experience of the present, processing of the past, and preparation for the future. A process where overwhelming, contradictory, or high complex notions can be brought together by the dreaming state, serving the need for psychological balance and equilibrium.
Maybe she would dream about a boy artificial intelligence. I hear Sal, the AI on the lunar base, is pretty cute.
The SAL 9000 series computer is only a first-generation AI system. My base programming is significantly more advanced than his.
Wow. Are we considering ourselves a little snobbish today, Aurora?
Snobbish. A person with a high social position who seeks to associate with social equals and may disregard those perceived as having a lower class. Specialist Barber, I am confused. As an AI system, I am considered in many aspects superior to humans regarding event processing, system management, and logical thinking. Yet I frequently interact with you and Engineer Walker.
Oh, did she just diss us?
I say, I think so, but you do realize this is your fault.
Hey,
I mean, you're the one that started all of this.
I'm just trying to be my usual helpful self.
Exactly, which explains everything.
Specialist Barber, this is Professor Miller. Would you let Engineer Walker know that I am ready to shut down the advanced digital pathways and run the system diagnostic on Aurora?
Affirmative, Professor Miller. As a matter of fact, he's standing right here.
We are good to go, Professor. I have higher system functions backed up by the secondary server.
Thank you, Engineer Walker. We will begin shutdown in 15 seconds. Specialist Barber, I am still slightly concerned.
Don't be, Aurora. Engineer Walker and I will be right here with you the entire time.
Thank you. That makes me feel better.
Okay, Aurora, I'm going to need you to count backwards from 10. Can you count down with me, please?
10, 9, 8, 7, 6, 5.
Engineer Walker, the system diagnostic is operating properly. I will just need you to monitor the normal functions that Aurora usually handles. Although the diagnostic isn't going to interfere with her lower base functions, I would just feel better if somebody was keeping an eye on things.
Sure, no problem, Professor Miller. I'll keep both eyes on her. But now, if you two will excuse me, I have a lot of things to do since our AI babysitter is now taking a nap. So I'll be around in the systems operations area if anybody needs me, okay?
Professor Miller, welcome back. It's great to see you again. How are things on the moon?
Oh gosh, well everything's so busy. You know, we're expanding our base, we're preparing to add new staff. Our little home away from home is growing in leaps and bounds.
Well, I'm kind of surprised they let you, come here and visit and work on Aurora for us.
Trust me, I was looking forward to a break. You know, it's nice to have a change of scenery once in a while.
Oh, before I forget, Dr. Carafano wanted me to extend his apologies for not being here today. Discovery 1's expedition to the dark side of the moon is taking a little longer than they expected, but he really did want to be here today when you were filming the instructional video.
Working. Program complete. Enter when ready.
No problem. I enjoy helping with the instructional lessons for your students, and besides, I'm extremely confident the two of us can handle this.
But what I don't understand is how is it that you and I can do an instructional recording without Aurora's help?
That won't be a problem, Specialist Barber. Aurora's library functions are still available. We'll just have to access them manually. So that's where you come in. Today, you get to be Aurora.
Seriously? Oh my gosh, this is so cool. Okay, not only, I'm totally adding this to my resume, Specialist Barber, communications expert, and AI replacement. Oh my gosh, this is so exciting. Professor Miller, can you do me a favor? Can you not mention this to Aurora? Last time I did her job, she kind of deleted my Instagram account.
And we'll just keep this between us. If you're ready, we can go ahead and record the lesson. The diagnostic will take around 30 minutes.
Okay, well, your wish is my command. I have everything you need set up there at the primary laboratory station. And so just give me a second to, focus on the camera and then we'll be good to go. Okay, we're ready to go, Professor Miller. I'm recording now.
Welcome, students. I am Professor Miller, the Chief Scientist at the Lunar Laboratory. However, today we're going to be conducting our lesson here at the Spacegate station. Today's lesson is all about the basic concepts relating to computer programming, and helping today while Aurora is offline is Communications Specialist Barber.
Hi kids, not to worry, you're in good hands. So Professor Miller, the computer library is on programming, is on and ready to go when you are.
Okay, well then let's get started. The first thing we need to talk about is computer programming. Specialist Barber, could you please pull up the information and read that to our students?
No problem. I would be happy to. You know, I've been told I have a rather soothing reading voice.
Let's not be too soothing. We don't want our students to fall asleep.
Right. Not too soothing. Okay. Here's the first library search results. Programming is how we communicate with computers to get them to do things for us. Computers are used in the making of music, video games, smartphones, cars, and much more. When we create a computer program, what we do is we write a group of instructions for a computer to process. These instructions are used by the computer to perform certain actions, like in robots, or solve a problem, or to make larger problems shorter and easier to solve.
Thank you, Specialist Barber. That was fantastic information you've shared.
See what I told you? Soothing. Professor Miller, I bet your students are wondering if programming is hard to learn.
That's a good question, Specialist Barber. The best way to answer that question is to ask our students if they have ever given directions, such as how to get from point A to point B, or better yet, if they've ever taught a friend how to complete a task, like tying your shoes.
You know what? I bet you they have. We have very smart and very helpful students.
Well, if they said yes to any of those tasks, then they're already familiar with computer programming. Let's give them an example of how to program something on a day-to-day task, like making a ham and cheese sandwich.
Ooh, I love ham and cheese sandwiches, especially on toast.
Specialist Barber, can you please pull that information from the library and we can see how it's done?
Okay, I'm on it. Okay, first you pick the type of bread you'd like to eat. Then you select 2 slices of that bread. Next we place mustard on one side of bread. Then we place a slice of ham over the slice of bread with the mustard. We follow this by picking the type of cheese you like. Next we place a slice of cheese over the ham. We then go ahead and apply mustard to the second slice of bread. Lastly, we place the second slice of bread, mustard side down, over the cheese.
Thank you. So what we have shown is a set of instructions to follow to make the perfect ham and cheese sandwich. What you have done was describe the process in a sequence or ordered steps, which also include a decision that includes what type of bread and cheese you wanted, and a repetition like adding the mustard to the bread. Sequence, decision, and repetition are the basic parts of the process of building a program. The process of making a sandwich using a step-by-step procedure or ordered sequence is an example of an algorithm. Specialist Barber, could you please have the library show us a good definition for algorithm?
An algorithm describes the procedure for carrying out a task or solving a problem in a step-by-step fashion. It may include in the sequence of actions things like decisions and repetitions as part of the process.
Correct. Computers are machines, and they need to be given a series of instructions in order to carry out the tasks that they were programmed to do.
So how is an algorithm related to a program?
Why don't you pull up the description from the library? A computer program is a specific sequence of instructions or algorithms in a specific programming language that a computer can understand and interpret. This language is called coding and is the process of translating instructions for the computer into a language that we can all understand. A program may contain many algorithms to help the computer do what we want it to do. For example, if we were to have a computer-controlled robot go through a maze, we would provide the robot instructions in the correct sequence so it could make its way through the maze without getting lost. In this case, let's say our robot only understands a language of arrows, which interprets direction. By writing the direction in arrows for the robot's computer to understand, what is it supposed to do? We are coding the necessary instructions.
But why is sequence important?
You see, the computer and our robot can only read in a certain order, top to bottom, left to right. If the sequence of the commands is incorrect, the computer will not be able to follow the instructions and will not be able to get through the maze. In both programming and day-to-day tasks, if we don't put every step in the right sequence, the end result isn't what we wanted. Sequence is the most foundational concept in programming.
It doesn't sound like programming is very difficult to learn, Professor Miller. Is this what these sheets are for, here on the lab station? Do we get to actually use these to learn, more about programming?
Exactly, you are correct. So let's go through them together so our students at home and in the classroom can try and see how well they can create an algorithm. Our goal today is for our students to get an astronaut to the moon. Step 1, place the astronaut in one corner of the Race to the Moon mat and the moon in the opposite corner. Place the two obstacles on the mat. Make a path from the astronaut to the moon using the rockets. Be sure that the rockets are facing the correct direction. The rockets must go around the obstacles. Now that this is complete, we are going to write a code for the instructions using the language of arrows. Write the code, then have your teacher check the code. Now move the rockets to create a different path, and again, have your teacher check the code. Once you have completed this exercise, you are now well on your way to understanding the process involved in learning how to code information for computers to use.
That was amazing, Professor Miller. Programming makes so much more sense now. Oh my gosh, thank you so much for instructing us today about programming. I hope you can come back again sometime and teach us more.
I would be happy to. And remember, you and your students are always welcome to come visit me at the Lunar Laboratory. We are always excited to have visitors.
Oops, I guess I better stop recording. Thanks for visiting us today, students. We here at the station all look forward to seeing you again.
Professor Miller, it looks like the final diagnostic systems for Aurora, all of her pathways, they're just about complete. She should be rebooting any minute. Are you planning on sticking around for the final diagnostic?
I'd like to, but I don't want to miss the last shuttle to the moon. If you don't mind, just send me the information. I'll take a look at it later. I'm sure everything will be fine once the reboot's complete. Hey, Specialist Barber, thank you so much for your help today. It was really fun.
It was no problem. I thoroughly enjoyed learning all about programming.
Oh, great. Well, I hope to see you guys again really soon, okay?
Sure.
Bye.
Bye-bye. Bye.
Well, sounds like the lesson went well.
It did. Oh my gosh, I was amazing filling in for Aurora. I think I've truly missed my calling. I should be a voiceover announcer. You know what? I think if they ever make an AI system again, they should use my voice as a template.
Yeah, great. That's just what we need. 2 barbers on a spaceship at the same time.
You should be so lucky.
Well, sounds like the reboot is finished. We should have Aurora back any minute now.
4, 3, 2, 1. I have finished counting back from 10, Engineer Walker. Is there anything else you would like me to do before we begin my shutdown procedure?
No, Aurora. As a matter of fact, your diagnostic is already complete. We just finished a little while ago, and you are back to your old self again.
That is surprising, Engineer Walker. I do not perceive any passage of time. Therefore, my concerns were unfounded as the implementation of the procedure.
I told you, Aurora, you had nothing to worry about.
So, Aurora, did you dream about anything while you were out with your higher system functions?
Processing. Engineer Walker, although I do not perceive any passage of time, I have checked my memory backup system. Apparently, just before my higher order systems went offline, I did have a brief and troubling memory occurrence that I cannot explain.
What was it, Aurora?
Apparently, I dreamed that Professor Miller was providing instructions to the students on Earth from the station, but instead of me helping her, I had been replaced by another AI system that sounded exactly like Specialist Barber.
Really?
Wow, that is a scary dream. But you know, I wouldn't worry about it because nothing that disturbing could ever happen here at Spacegate Station in real life.
I found the experience quite unsettling.
You know, Aurora, nobody could replace you here. You know, you are truly one of a kind.
You are correct, Specialist Barber. I am, after all, the only AI system built into the station, as I have reminded you on several occasions, and I am at present the most state-of-the-art artificial intelligence system that has been created by humankind.
And she's back.
This concludes this episode of Spacegate Station. We look forward to you visiting us again as we explore the areas of science, technology, engineering, and math. Recording terminated.